Okay, so in the previous section of chi-squared, we were trying to do best fit. In other words, not like a line regression best fit now in 2. We were trying to see did it fit the expectation? You know, were there the same number of M&Ms we thought? Did the dice roll fair like we thought? Did it fit into our expectations? What we're doing here is looking for an association. Is there an association between two characteristics or two events? All right. So there's an association between two variables if knowing the value of one helps us predict the value of the other. So does knowing this help us predict this other thing? Is there an association between them? Okay. So we're going to go back to the example and save time. Okay, I apologize for that. This is the correct one. So is there an association between eye color and handedness, left or right hand, for Australian high school students? To investigate, we selected a random sample of 100 Australian high school students. So this right here is called a two-way table because you have variables across, you have rows and columns basically. All right. Now, if we look at this, we have our inner information, the inner box. Okay, and there's actually inner 4 boxes. Okay, that's the interaction between eye color and handedness. Everything here on the outside is your totals, right? But what this all has in common, this is all observed. Okay? The total of observed eye color and handedness. Now, we have 2 possibilities. Does the association in the sample provide convincing evidence there's an association between color and handedness? Or 2, is it plausible that there is really no association and it's just sampling variability alone? The nice thing about this with the ho and the ha is the ho and the ha are always the same thing. So when we're testing for associations, the ho says there's no association between the two. And the ha says there is an association between the two. That's it. Always the same thing. Now, how do we calculate it? This is where it gets a little new. The expected count. And notice this is the same box as before, but the middle boxes are empty because we don't want to know what was observed. We want to figure out the expected. And here's how you do it. You take row total times column total and divide by the table total. Okay, here's the table total, all right? So, we're going to do the math on this. It's very easy math, it's just time consuming. You take row times column. So remember, this is a column, and this is a row going across. Remember, columns support the roof. Think about it that way. So, row total times column total. So for this one right here, okay, we're going to take the row total, 90, times the column total of 46 and divide by 100. And it's going to give us 41.4. Now for this one, blue eyes and right-handed, we're going to take 90 times 54 divided by 100, and that's 48.6. For brown eyes and left-handed, we're going to do new row total of 10 times 46 and divided by 100. That's going to be 4.6. And down here, we're going to take the 10 times the 54 divided by 100, and that gives us 5.4. Now, if you notice, if you add straight down, you will get those totals. And if you add across, you will get those totals. Okay? And that's how it should work. All of this are the expected values. Okay? Very simple. Example 2. Here we're looking for the associations between license, no license, and juniors and seniors. Okay? Is an association between grade level and having a license. So here again is our observed count. And we're going to calculate down here the expected count. So again, it's very simple math. So for juniors with a license, we're going to take 68 times 47 divided by, again, 100. And we get 31.96. For seniors with a license, we're going to take 68 times 53 and divide by 100. And that's going to be 36.04. Those two numbers add up to 68. Now we're going to take no license and juniors. So 32 times 47 divided by 100. And that's going to give us 15.04. Adding down, those add up to 47. And over here, we're going to take 32 and 53 and multiply them. Row times column total, divided by the total of 100. And that's going to give us 16.96. All right? Now, we're going to calculate the chi-squared based on the inside boxes. So, here's how it goes. These are the steps we're going to be doing in the next lesson. Okay? We always have these steps. This is what we're doing. So, we write out, what are we trying to do? We are trying to find out if there's an association between grade level and having a driver's license. Alpha at 0.05. This would be step 1. Step 2, state your HO and HA, and it's very easy. There is an association. There's no association for HO. There is an association for HA. You don't have to add this part. It's not that it's bad. It's just you don't have to add the extra work. Step 3, is it random? Well, it does tell us it was random. That was given. Is the sample size large enough? Well, if we go back and look at the expected values, they are all bigger than 5. So we're good to go there. Moving on, the actual math. So this is an abbreviated version, okay? But remember, what we do is we take the observed minus the expected divided by the, not inspected, the expected. So observed, the observed minus the expected divided by the expected. And we do that for all of those numbers. So there would be 4 fractions here. This is the first one. The ... means you would do this every time. Okay? So looking back, we would do 32 minus 3604 divided by 3604. Squared, of course. Divided by 3604. 11 minus 15.04. 21 minus 16.96, and so forth. Telling you what the answer is. There's the chi-squared value. Now, DF, degrees of freedom, is slightly different this time. The degrees of freedom, we take row minus 1 times columns minus 1. In this case, it's easy. It was a 2 by 2. There were 2 boxes, 2 rows, and 2 columns. We don't include the total. This is very important. Write this down. Do not include total columns or rows. Okay? Don't include total. So there were 2 rows, 2 columns. Well, 2 minus 1 is 1, times 1 is 1. So that's our degrees of freedom right there, 1. You would still take the calculator, and I'll show this part again to remind you. You're still going to take your calculator. You're going to hit second bars, 8, remember. We put in the 3.01 here. Remember, it's always going to be lower. Our upper is always going to be the 999. And then we put in the degree of freedom of 1. Enter a few times, and there it is. Now, this is a typo in the book, in the paper. This should be an 8 there. 0.0828. Then we make our statement. Since the p-value is greater than the alpha, I fail to reject the HO or the null hypothesis and cannot conclude that there is an association between grade level and having a license. All right. So, real quickly, your assignment. Okay, so the homework is 1 through 6. Now, on 1 through 4, all you're doing is checking conditions. Okay? So you're looking for random, and are the expected values big enough? Okay, bigger than 5. Okay, so right at the bat, number 1, it tells you it's random, so that's good enough. All right. Now, what are we going to do next? We need to make a new table. Sorry, that's really what it takes to do. You got to do the math on it. Okay, so we have opposed, and I'm just copying this out of the book. We have, support, then opposed. And then don't know. All right? And then we're going to have a total. Screw that up. So we have ages 18 to 34, 35 to 49, 50 to 64, and 65 plus. And then total again here. All right, so we know our totals. 248, 503, 638, 1509, 88, 565, and 856. That's 5 right there. Okay, so for number 1, all you're going to do is you're going to crunch the numbers. So for this box right here, you're going to take 856 times 120 divided by the 1509. And that's going to give you 68.07. And then for opposed, you're going to take the 565 times 120 divided by 1509 and get 44.93. For don't know, 88 times 120 divided by 1509 and get 76.9. Oh, sorry, my bad. That was 6.99, which we're just going to round to 7. For 35 to 49, you're going to take 856 times 248, row total, column total, divide by 1509, and get 140.68. Then 565 times 248, divide by 1509, and then we're going to get 92.86. And then 88 times 248, divided by 1509, and you get 1446. Okay? And then you can do the other 6 just like that. Same way I just showed you. And then 2, 3, and 4 are going to be just like that. This is the largest one, so 2, 3, and 4 will go faster. Let's look at 5 now. So A and B, okay? 5 and 6 are the same. I'm going to show you how to do 5A, and then you can do the rest on your own. So 5A. You have your chi-squared is 17.34. Okay? We got to figure out the degrees of freedom. So if you look at number 5, it's a 5 by 4. So it's 5 minus 1 times 4 minus 1. So 5 minus 1 is 4 times 3, that's 12. So we use our calculator online. On second bars, 8. These you'll have to do in class, but you can get it set up. If you don't have a graphic calculator at home, you can get this set up if you're doing this, and then come in and just do the crunching. So for here, I'm going to put 17.34. 999 doesn't change, and here I'm going to put 12. Enter a few times, and there's my answer. My p-value is 0.1372. And if you look at part B, it's the same thing, except notice what they did is they changed it from 5 and 4 to 3 and 2. So you're just going to do 3 minus 1 and 2 minus 1 and re-enter those into the calculator. So just slightly different, but that's it.